Hi AP students, we are going to learn today how to make ricotta cheese. And in front of you I have all the equipment and materials you're going to need. It's really simple. You're going to need milk. The recipe calls for a half a gallon to make about a cup of cheese, but if you want to make less, you could use less milk. You just have to adjust your other measurements accordingly. So you're going to need milk, a form of acid. I'm just using plain old white vinegar, but you could also use lemon juice or other types of vinegar in the process, and salt. That's all you need to make cheese. Now in regards to equipment, I have a large pot that I'm going to heat my milk up in. I have a bowl that I'm going to use. I'm using a strainer to hold this material, which is called cheesecloth. Now cheesecloth is basically this kind of mesh material that's going to allow liquid to drain and keep our solids in place. If you don't have this, you could use a thin towel or things like that, anything that's going to drain the liquid but hold on to your solids. You're also going to need some measuring equipment such as a measuring cup and tablespoons. The first thing I'm going to do is I'm going to get my milk heated on the stove. I am heating my milk up on medium heat, and I'm just stirring it every so often so that it doesn't stick or burn on the bottom. Now, whenever you are cooking anything on the stove, you should use adult supervision. So my milk has been heating up on the stove for about 10 minutes, and you can see it's nice and steamy. Now what I'm going to add to it next is vinegar. And watch what happens to the milk as I stir. So we will see that the milk starts to look a little bit different. What's happening is it's curdling. Okay, we can see that we are getting chunks of milk proteins and fats, and it's separating away from the whey, which is the liquid. Okay, so I have created curds and whey. The process of adding acid and heat is what is causing my proteins to denature and to form cheese curds. I have taken my milk off my stove and I'm letting it cool down. You can see that it definitely looks different from what I started with. It's now almost like a yellowish in color, and it's full of those chunky cheese curds. So now what I'm going to do is I'm going to pour it into my bowl. And in order to strain the whey from the curds, I have a colander and I've lined it with cheesecloth. And like I said, if you don't have cheesecloth, try a tea towel or some sort of thin towel. That might help you. So something like this, which is thinner in material that will let water or the liquid travel through easily. Okay, so I'm just gonna pour this into my colander. I'm gonna probably have to do it in a few shifts to get all that whey separated. Okay, so you can see in what's draining out, all this yellow liquid, that is my whey. And left behind are my cheese curds, so that is my cheese. So I'm gonna go ahead and I'm going to dump out this whey, and then I'm gonna do the rest of my milk. Okay, so I'm gonna make sure I scrape it down. I'm also using a spatula, okay? And I'm just gonna dump it into my cheesecloth. Try to collect all the curds that I can. So you can see it kind of draining through. Now it might take a little bit of time, especially if you're not using cheesecloth, if you're using muslin or something like that to strain. But we're trying to get out as much liquid as we can because we would like a solid cheese rather than very liquidy, runny cheese like you can see now. I'm just gonna dump my whey one more time. And I'm gonna let this sit and strain and cool a little bit for a few minutes, and I'll check back in and I'll show you guys my my cheese product when it's done. I have let my cheese sit in the cheesecloth on the colander for a few more minutes to let it strain. If you really want to get it dried out, you can pick up the cheesecloth and wring it out and wring out some of that extra whey. Cheesemakers, when they try to make a firmer cheese, like a feta cheese or something like that, they will let it strain for a long period of time. Your last step is going to be seasoning your cheese. So after you've had it strained, you're going to go ahead and put it in another dish. Okay. There's your cheese curds. You can see how it's definitely solid compared to what it was before. The cheesecloth you can just get rid of. Okay, and then you're going to season it to your taste. So the recipe calls for, a quarter teaspoon of salt. However, if you like more or less salt, you can kind of add accordingly. So the saltier you want your cheese to be, the more salt you need to add. So something like a feta cheese would have a lot more salt than, say, a ricotta cheese. So you just mix in that salt, and you can see that you have your soft, crumbly cheese. You can go ahead and try it on a cracker or on a piece of toast. If you want to make maybe some Italian food, this is the filling of lasagna or ravioli, so you can go ahead and give that a shot. I hope you guys enjoyed making cheese. I hope you guys give it a shot. There is one last thing I forgot to mention. When you're buying milk, I used whole milk just because it has more fat in it, and so it tastes a little better in the end. However, you could use any level of fat in your milk. Also, make sure your milk is not ultra pasteurized. Okay, ultra pasteurized milk has been heated, and so it can stay and remain on shelf stable for a really long time, and that alters the proteins. So you want a milk that says it's pasteurized, okay, in order to make it form curds like this. So enjoy doing some kitchen chemistry. Cheese. I showed you how you could use changes in pH and temperature to denature the proteins to cause cheese curds to form. Well, that works for ricotta cheese and soft cheeses, but many cheeses rely on enzymes to coagulate the milk and form cheese curds. The most common enzyme used is called chymosin. In the dairy world, they call it rennet or renin. And this enzyme digests proteins, and it allows cheese curds to form. So as you can see the casein proteins. Those proteins are forming like little globs in the milk. Okay, there are also fat molecules that are all clustered together to form fat globules. And sometimes cheesemakers will add bacteria and other microorganisms to add different flavors to the cheese product. Well, when you add rennet or change the pH or change the temperature, all of those will work to kind of break apart these casein proteins, and they begin to unravel as they lose these secondary and tertiary interactions between the amino acids. As a result, these proteins now have exposed hydrophobic regions. And those hydrophobic regions stick together and form almost this mesh-like network. Now, this mesh of proteins traps fats, traps bacteria and other flavorings involved, and that is what you see when you see cheese curds. Now, chymosin that is used to make cheese comes from 3 different places. So here's the general structure of this enzyme. You can see it's got this active site, okay? Sometimes it comes from, so it's vegetable rennet right here, and it comes from a thistle plant, and that enzyme derived from this thistle can be used to digest milk proteins. It also can come from animals or from microbes, and we're going to focus on this animal and microbial rennet as well. So let's look at animal rennet. So baby cows or calves drink milk as their primary food source when they're very young. So Animal rennet can be harvested from the stomachs of calves, and they can collect this enzyme from the stomach and then use it to digest milk. So the baby would use this chymosin enzyme that's normally in its stomach to help digest the milk it's drinking from its mother. And dairy farmers can harvest it from dead calves and take their stomachs and extract this enzyme and then use it in the cheese making process. This is traditionally how cheese was made, is using animal-based rennet from calf stomachs. Today, only about 5% of cheese made in the United States still uses animal rennet. An even smaller portion tends to use the vegetable rennet from thistles. So where does the rest of the rennet come from? Well, the vast majority of rennet used, or this chymosin enzyme used, comes from microbes. It's also called fermentation-produced chymosin, and it is made through genetic engineering. So what scientists were able to do, because animal rennet relies on calves, right? And having a steady supply of calves isn't always available. So they don't always have calves year round to supply rennet to make cheese. Also, as people stopped eating veal and other products from calves, there wasn't really a high demand to slaughter calves. And so it became very hard for cheesemakers to get the rennet that they needed at an affordable price. So what scientists figured out they could do was they could take some of the cells from a calf that would normally be expressing this chymosin gene, and using enzymes, they can cut the chymosin gene out of the calf genome. So they're basically taking the directions for how to make cow-based chymosin. They're going to cut it out using enzymes called restriction enzymes. And then they can put that chymosin gene into something called a plasmid. A plasmid is a ring of DNA that some cells have in addition to their normal chromosomes. So they're extra chromosomal rings of DNA. And they're typically found in bacteria cells, or they can also be found in yeast cells. So using an enzyme called ligase, they can join together the chymosin gene to this plasmid, and then they can put that plasmid inside yeast cells. Yeast doesn't normally make cow chymosin, but now it has the gene, and it can go ahead and transcribe and translate that gene to produce chymosin protein. And because the yeast doesn't naturally do this or make this, scientists can then filter off this chymosin and use it as this rennet for making cheese. So over 90% of the cheese made in the United States is actually made using chymosin produced by genetically engineered microbes. So although you might buy cheese from the store and it won't be labeled as genetically modified, okay, actually the rennet that was used to create the cheese probably came from a genetically modified organism. So let's just look at the cheese making process, the industrial cheese making process. So like we had seen in my kitchen, okay, cheese making involves kind of this coagulation, this curdling. So heating up, adding some sort of acid or rennet to the milk. And then you can also add other microorganisms that might add different flavors to your cheese curds. Okay, once the curds have formed, they're going to be cut into pieces. They're going to be the whey is going to be drained off of them, and then they're going to be cut finer. And then for something like cheddar cheese or Gouda or even Parmesan, they'll take those cheese curds and then they'll press them into a mold to get that kind of characteristic round shape. And then they let them ripen. So they let them sit for a while to let some of the moisture evaporate out of them and let some of those microorganisms that might have been added kind of do their stuff to kind of get some of those funky cheese flavors. Now, I made cheese really simply with ricotta, just using heat and acid. But if you want to try making cheese with rennet, you can actually buy kits to do it. I'm recommending kits from the New England cheese making supply company. So here you can see these over here. And this is me in the past. This is me making fresh mozzarella curds, okay, using one of these kits. And it comes with some of the materials you might need, such as the rennet tablets or some of the bacteria that you might need if you're going to make cheddar, things like that. So if you want to explore cheese making with enzymes, I encourage you to look and see there are lots of different companies that sell kits. This was just one that I happened to know. I think it's really important that you guys understand where your food comes from and the chemistry that is involved with it.